Okay. Okay, yeah, good evening, everyone. Yeah, welcome to today's class. Okay, so I'm going to be sharing my screen quickly. Just a second. Okay. Okay, so today we're going to be looking at lists in Kotlin. Okay, we'll be talking about lists in Kotlin. Okay, so we've learned about some basic data types. Okay, we learned about int, double, we've learned about Boolean, string. Okay, so they actually allow you to store a certain type of value within a variable. Okay, but what if you wanted to store more than one value? Okay, so that is where having a list data type is actually what's useful. Okay, so what is a list? So basically a list is a collection of items with a specific order. Okay, a list is a collection of items with a specific order. And there are two types of lists in Kotlin. Okay, there are two types of lists. We have the read-only, and then so we have the read-only, which is you see it as lists, and then we have the mutable lists. Okay, we have the mutable list. Now, so the read-only lists, it's the list, you have the capital L, but the mutable list, you see it as mutable list. So the read-only list, of course, it as it says read-only, it cannot be modified after you've created it. You can't modify it. You can't add an element to it. You can remove. You can't change or whatever. But the mutable list, okay, can be modified after you create it, meaning that you can add, you can remove, or update the elements in it. Okay, so when you're using lists or mutable lists, okay, you must specify the type of element that it can contain. Okay, you must specify. So basically, what am I saying? You need to have, so you can see something like list. You're creating a list, then you must specify the data type, the type of element that it should actually have. And here I'm going to say, let's say int. So basically, what am I saying? That my list should have elements of integer data type. Okay, elements that holds a list of integers, okay, or integer values. Okay, you could actually have a list. Sorry, you can have a list which probably has just strings as the element, string elements inside of it. So it holds just a list of strings. The other one holds a list of integers. Okay, so let's say so. So if you define a car class in your program, you can have a list that's also adding an object, like class. So you can also have a list. Sorry. You can have a list of car. So this holds a list of car object instances. Okay. So, well, of course, the best way to understand lists is to actually try them out. So let's do that. So let's create a list. Okay. So to create a list, I'm going to create a variable. I'm going to call it numbers. So the variable we called numbers. And this number variable, I want it to be of type list that holds integer values. So our numbers of the list type of a list data type that stores just integer values, that has a list of integer values. Okay, so of course this is going to be a read only. That's why we're using the list, just list. Okay, so and then we can now pass in. So how do we now initialize this? Okay, how do we initialize it? We use this by using we use that by calling the list of. Okay. So list of what? So since we said integers, so we can say 0, 1, 2, 3, 4. Can actually just do that. Okay. So what does this do? This returns, this is just actually what holding list of numbers, which is 0, 1, 2, 3, 4. Okay, so this will return a list, a read-only list of integers from 0 to 4. To 4, from 0 to what? 4. Okay, so now, but if the type of the variable can be guessed or inferred, okay, based on the value on the right, you may not have to add this. Okay, so we could also decide to take out this, and then of course by inference, type inference, this actually still works. So let's actually see that, and then so let's do something. So I'm going to print this list. So let's use a strings template. So let's run this and see what we have. Okay, so you can see we have what? List, and we have 0, 1, 2, 3, 4. I trust you can hear me. So if you have questions at any point, please just, drop a message. Okay, you can just drop a message, or you just raise your hand. Okay, or you can actually just unmute. I think that also will be fine. But let's do that. Let's see. Okay, so let's move on. Now, we can also check to retrieve the size of a list. Okay, we can check to retrieve the size of a list using the property. So it has an access property. You can actually use the access property method. So let me just do this. Okay, good. So I could say numbers dot size. I want to access the what? Size. Okay, I want to access the size. So, well, let's just do this so we can still preserve the first print statement. So I'm just going to take out this, and then I'm going to say size. Okay. Okay, so let's run this. So we have a list, and then we have a size of what? 5. That means it has 5 elements. Okay, it has 5 elements what in that what list. Okay, so let's just do this. So how do we access list elements? Okay, how do we access list elements? So I think at this point I'm gonna have to do a bit of drawing on this screen. So I just hope you can see my screen. So so pardon me, I may not actually draw this very well, but so let's look at something like this. So let's have 1, 2, okay, 3, and then 4, and then 5, and then 6. Okay, that's a very funny looking 6. Okay, so these are the elements. Okay, so these are the elements. Ooh, that's interesting. Using a mouse is actually very interesting. Okay, so these are the elements. Okay, so I want us to actually understand this now. Now, the functionality specific to lists is that you can access each element of a list by its index. Okay, you can access each element of a list by its what? Index. So of course, the index is actually an integer number that represents the position. Okay, so this is just let's say this is a list of numbers 1, 2, 3, 4, 5, 6. Okay, and then showing the elements, and then I want to show the corresponding index. So we have an arrow here, we have an arrow here. So create another arrow. So just like a pointer though. So this first element has an index of 0, this has an index of 1, this has an index of 2, it's an index of 3, has an index of 4, and then this has an index of 5. So this represents the word index. Okay, so the index is actually an offset from the first element. That means when you have a list, okay, that says 2, okay, when you have something like this, you know, lists. Oh, okay, maybe I can just actually, let me just type that out. Okay, so when you have something like this, lists, and you have something like this, okay, so when you say something like this, what you're basically saying, you are not asking for the second element. Okay, no, that is not what you're asking for. When you say list and then you pass in 2, you're not asking for the second element of the list, no, but for the elements in this 2 position, in the position 2, okay, offset from the first element. So basically what I'm saying is, you know, in lists, okay, of course, programming actually in general, counting starts from 0, you know, 0, 1, 2, 3, 4, and the like. So in a list, the first element has an index of 0. Okay, the first element has an index of what? 0. Okay, so when you have list 0, this is going to give you the first element, that's a 0 offset. When you have 1, this is going to give you the second element, that is an offset of 1, that's 2 minus 1. When you ask for this, this gives you the what? Third element, which is offset of 2, and so on and so forth. Okay, so just take note of that. So with that being said, let's now print out some of these elements. Okay, let's print out some of these elements. So I think I can clear this drawing now. So okay, let's clear that quickly, or maybe we should just leave it for a while. So let's leave it for a while, and then let me edit this to have the same elements here. And then 6. Okay, good. So I want to now print, I want to get the let's say the element, the first element. So let me print the first element. So how do I do that? So I'm just going to say print line. Okay. So first element. Okay. So numbers. Okay, and then we use our square brackets to denote the index. So to get the index. Now, so if we were thinking that the first element would be, you know, we use 1 to denote the first element. No. So if I run this, it's, if you think that, then that means it should actually give us 1. But if you see, it gives us what? 2. So the first element is actually what? 0. Starts at the indexing starts at 0. So we should have what? First element is what? 1. So the second element, to print the second element, okay, the second element will be at index of what? 1. And then we'll run it. Sorry, need to change this to second. And then we have that second element, what is what? 2. Okay, so well, that's actually what that's actually what that. So our indices actually run from 0 to what? 5. Okay, so we can actually print the last element of the list using the size minus 1 to calculate it. Okay, because you may not, sometimes you may not know the size, so we can actually do that. I could just say last element will be numbers dot size minus what? 1, because of that offset, because of the offset. So we're running this, we should have last element is what? 5. Okay, no, that's so sorry. So yeah, okay, this gives us the last index, rather, sorry. Yeah, this gives us the last index. Yes, the last index. But if we want the last element, okay, So this gives us the last index. So I can just add a comment here, prints last index. So if we want to get the last, if we want the last element, okay, so what I'm just going to do, first of all, I'll call my list. So let me just delete this so it doesn't confuse us. So I'll call my list, which is the numbers, okay? And then inside, I'm going to now say, because since I want to get the last index, because the last index that will give me the last element, I'm now going to say numbers.size minus 1. So this should give me print out 6. Last elements. Last element should be 6, yes. So that's actually that. So Kotlin also supports some methods, first, last, okay? These are operations that can be done on a list, okay? So let's see. I can say something like, let's say first, and then I'm going to say numbers dot first, okay? And let's just try out the last, numbers dot last. So this should give us the last, the first and the last, elements. So you can see the first element is 1 and the last element is 6. Sorry, I have to change this to last. Yeah, the last element is actually what 6, which is what we actually have here. Okay, another useful operation on list is the contains method. That's another useful operation on list, the contains method. Okay, use it to find out if a given element is in the list. So like I could check if maybe 4 is in the list, and then what will it return? So let me see. I could just say print line contains, does it contain 3? Contains 3, then I'm going to now say numbers dot, then I'll call the contains dot contains. So I want to check what does it contain 3? So I'll pass in 3 there. I'll pass in 3, and then so when I run this, it returns a Boolean, so true, because 3 is actually contained there. That means the list actually has a 3. But if we actually check for a number that doesn't have, let's say, a 7, okay, this should actually give us a false. So contains 7, we should see false. Yeah, you can actually see that, see false. Let me zoom in a bit. Okay. Okay, so that's actually, yeah, so that's that. So that's actually that. So lists, okay, like we said, they are read only. Okay, they are what? Read only. So let's do something else. Let's clear this out. So I think I can clear this. Let's clear the drawing. Okay. And then okay, yes. Okay, so let's take this out. Okay, so now lists are read only, okay, like we actually said, okay, you can actually modify it. So let's create another list, okay. I'm going to call it colors, and it's going to be a list of colors. So I'll pass in, so now we're using strings now instead of numbers. So I'm going to say green, I'm going to say orange, and then I'm going to say blue. Okay, so remember, we can actually add or change elements to a list. Okay. Okay, so let's try something. We're going to now use the add method. So assuming I want to add to this, let's say, so I'm going to say colors, I'll call colors, which is the list, then call the .add. What do I want to add? Let's say I want to add red to the list. Okay. Or, okay, let's just run this. So you see, so this has an unresolved reference for add. Okay, so let's see. Colors, assuming we wanted to do colors and then we pass it, they want to get, and maybe want to modify, like change the particular element in the 0 index. We want to give it a new value of, let's say blue, the 0 index. So running this also, okay, say unresolved reference, and then you have no set method providing array access and the like. So you can't actually do that. Okay, so let's now try something. Let's try something. So we can actually see that you can't actually change a read-only list. Okay, but there are some other operations you can actually do on a list that doesn't change. Okay, one of the things is that you can actually return a new list. And there are two operations. You have the sorted and reversed method. Now the reversed function, it will return a new list where the elements are in reverse order, while the sorted will return a new list where the elements are sorted in ascending order. So I'm going to just do this. So I'm going to say, let's just do a print line. So say reversed list, and so say colors dot reversed. Okay, and then let's just do for the other one. So print line, list. So let's now see the list that will be printed out, okay, when we reverse it. Colors. Okay, so let's run this. So you can see the reverse list now has blue, orange, and green, as against the previous list that started with a green. Okay, so the reversed returns a new list where the elements are in reverse order. Okay, so if we wanted to do the sorted, okay, so for run that, sort it in ascending order, so we should see blue, green, and then orange. Okay, so that's actually, so these are operations you can actually do to a list that does not change. Okay, so there are a lot of operations actually, but well, we'll get to use them as we move on. So now let's go to the lists that do change, which is the mutable lists. Okay, let's go to the mutable list. So mutable lists, they are lists that can be modified after creation. That means you can add, remove, or change items. You can do everything you can do with a read-only as well. You know, both the reverse and the sorted. Okay, so and then we create them by calling the mutable list of. So let's just do that. So how do we create a mutable list? Well, first, so just like we created the last one, so I'm going to say val learners, or let me call you guys devs, developers, okay. And then, so I'm creating an empty list, which is an empty mutable list. You can say mutable list of, okay. So now, so this is an empty one, okay. But we are not done. We need to actually initialize it, okay. But let me show you something. So you see, when I run this, it says not enough information to infer the type variable. Remember what we talked about type inference, but here it doesn't actually have enough information because you haven't even given it any value for it to, any data for it to actually do this inference. So when you want to actually declare, mean that when you want to just declare an empty mutable list, you actually have to pass in the type. So I'm going to say mutable list of, no, just mutable list rather, and then let's say string. So when I run this, I don't have any issues, okay, except that this is not used. Well, we'll use it. We'll use it. So that's that. So it's either you do it this way, okay, or you could actually just take out this and then say, pass it here like this. That means mutable list of what? String. So it's either that way or this way. So when you run this, you see we're fine, no errors. Everything is what? Good. So you can actually use val for mutable lists, okay? You can use a val just to know that, because the entries, that is the variable that contains a reference to the list, and that reference doesn't change, even if the contents of the list does. So assuming I want to print this dev, what would happen? Of course, it's an empty list. So, okay, so just give me, sorry, just a second, please. Okay, so okay, so someone is asking what's the difference between list of an array of. Don't worry, we'll get there. We'll get to arrays. Okay, let's not get ahead of ourselves. Okay, so this gives us an empty list. Okay, this gives us an empty list. So let's move on. So let's add elements to this list. Okay, let's add elements to this list. Now, we can actually add. So we're going to add developers. So I'm going to add in your names. I'm going to add some of your names. Let's actually see. So, and I could do that on the fly. Okay. So let me do something. So I want to. Okay, yeah. So let's continue. Sorry about that. Okay. So let's print. Let me print something now. So let me say add devs. Sorry, we're going to do this. Add devs. So I can actually just do add entries here. So I'm going to say devs dot, and then I'll call it add. Then I'm going to now pass in the name. So let me say Devtonia. Okay, so let's see what this would actually give us. And then let me now print the list. So devs. Okay, so let's run this and then let's see what we have. So you can see add devs. Okay, so it returns true. Okay, it returns true. And then, so that means it's what basically what just told you, look, okay, I've successfully was added. So this returns is a boolean, returns a true or a false. So it returns true. And then we can now see Devtonia is now part of the list. Okay, so this add function, okay, just returns true or false. So if the adding element is to list, if it's successful, then it is added, or otherwise it's actually what false. Then, so let's add another person. Let's add another person. So who is, let's add Z. Okay, and then let's run this. So you see we have, true. So that means also these two add functions were successful. So we have Devtonia, and then we actually have Z added to the list. So instead of adding elements one by one using the add function, you can actually add multiple elements at a time using add all. Okay, you can do that using what? Add all. So what do I mean? I could just do something like this. I could say val more devs. Okay, let me close this out. I could create a variable, call it more devs. And more devs, let's say mutable. Well, it could actually just be a list of. So list of who. So I'm going to say who are the persons in this. I need the names. Who are those here? Okay. So let me just. So we have Stoic, if I'm not mistaken. We have the Optimist. Is that? Don't even. I'm not really sure, but let's just think that's his name or something. Sorry.
There is Abdul.
Yeah,
Abdul Latif.
Yeah, so let's yeah, okay. So I created a list so where we have more devs, more developers. Okay, so I could then say, let's just do this print line. Okay, and then let me say add lists. So basically what I'll just do, I'm now going to say devs dot add all. Okay, we have the dots, what add, what all. So you can see it actually returns a boolean. So you can add, put in the elements, which could be an array, a collection, and the like. So let's just put it. So I'm going to put in the list I actually created, which is more devs. Okay. So yeah, and then after that is done, let's print the list to see what we have. So I'm going to run this then. So you can see, so this addition was successful. We had, after adding Devtonia and Z, we had this list. And then after successfully adding Stoic, Optimist, and Abdul, you see they get added. So add all is also another function that you can actually use. Okay, but let's see something. Assuming we want to just here, let's try something. Of course, now because this is actually a string, you can't add anything that's not a string. Okay, just take note of that, guys. Like I can't actually say devs, Well, I have the ability, but it's just not going to work. So let's say 1. Okay, you can see the integer literal does not conform to the expected types for string. So you can't add a different data type. So list should have just the element should be of one, data type. Okay. Yeah. So so you can also remove elements from a list. Okay, you can call the remove method. Okay, you can call the remove method. So I could say let me just use this. So I could say remove, well, stoic is not this call. So let me remove stoic. Remove stoic. And then, so what do? I will change this to remove. So I'm going to call the remove method. And then who do I want to remove? I then pass in stoic. That's who I want to remove. So, well, after that, of course, I have to print to be sure that he was removed. So I'm going to now print to see the list now. So you can see it, yes. So here, stoic was here, but when we removed stoic, it was successful. That's why we have true. And then in the new list, stoic can no longer be found. Okay, so but what happens if you remove an item that's not in the list? Okay, what happens if you remove an item that is not in the list? Well, of course, it will return false. Okay, it will return false. So you can actually just test that out actually on your own. And then you can also specify the index, or position of the element you want to remove. And then you use the method remove at. And then I can just say remove at index of, I still want, let's say, so from the list, the new list we have, which is Deftonia, Z, Stoic, Optimist. So if I want to still remove Stoic, so Stoic is at the index of, well, we'll count 0, 1, and then 2. So Stoic is at the index of 2. So remove at 2. So our list still does not have Stoic there. Okay, so that is what actually that. So the return value, okay, of the remove at is actually the actual element. That's why I can see remove stoic, remove at 2. So the return value, what it returned here is what the element. The return value is the element, while that the return value of the add word is a Boolean, which is either true or it is actually what? False. Okay, so that's actually that. And of course, if you want to clear the whole list, okay, you can actually use the word dot clear. Okay, you can use the word dot clear, and the dot clear would actually clear the whole list. So I could just do devs dot clear, and then just after that, I'll now print devs again. So when I run that, you can see we now have an empty list. After this, we clear the list, and then we have what's there is what's empty. Okay, so that's actually what that. Another thing you can also do, Kotlin gives you a way to check if a list is empty using the isEmpty function. Okay, using the what is empty function, and that will give you return either a true or a false. So I could say devs, I could just say devs dot is empty. Of course, I need to. Okay, so so devs dot is empty. Okay, sorry, I had to put the parentheses. So after clearing, you can see that devs dot is empty. It's telling you it is what's true. After clearing, that means it's true. It was able to clear that. Okay, so that's actually that. And then the next thing we're going to look at now is loops. Okay, we're going to look at loops. I really hope we're able to finish this. This is a long one because we need to understand lists before we actually even go to applying them in Android. Okay, so let's look at lists, looping through a list. So to perform an operation on an item in a list, okay, you can loop through the list, and looping is also known as iterating through. Okay, you can loop through the list or iterate through the list. So loops can actually be used with lists rather, and mutable lists. So the first one we're going to use is the while loop. Okay, while loop. So loops are just there, whatever used to repeat an action. Okay, so one of the type of loops we'll actually start with is the while loop. Okay, so a while loop starts with the while keyword. Okay, in Kotlin, it starts with the while keyword, and what it does, that it contains a block of code within curly braces that gets executed over and over again as long as the expression in the parentheses is true. Okay, so let's clear this out. Let's clear this off. So how do you, so this is a while loop, while, and then you pass in the expression, okay, and then the parentheses. So whatever whatever code you write in here gets executed over and over again, as long as whatever expression you have in these parentheses is what? True. Okay, but to prevent the code from executing forever, of course, that's called an infinite loop or infinite loop. Okay, the code block must contain logic that changes the value of the expression, so that eventually the expression will be what? False, and then you can stop the what? Loop. Okay, so at that point you exit the while loop and continue with executing the code that comes after the loop. So one thing to note is that a while loop doesn't need to involve a list. Okay, it's useful for a list, but it doesn't need to involve a list. Now let me show you something. So I could say, let's see if we can do an infinite loop. So I'm going to create a variable, val x, let's say x equals 5, val y equals 2. Now let me create that. This is an example of an infinite loop. While x is greater than y. Now, is x greater than y? Yes, 5 is greater than 2. It's not changing. Print infinite loop. So it will keep on executing this. As far as this is true, it will keep on executing this code inside. It will keep on executing it. So it has executed to the point that you now have this error. Exception in thread main, out of memory error. There's out of memory, like it has kept on executing and executing and executing. But I could say, okay, after you do the first two, after you print, I could reduce the value of x. So let's just make this a var. I could say, okay, while x is greater than y, print infinite loop. Okay, then I could now say x minus minus. I want to reduce x by 1. So that means later on, x will now be what? 4. It will run again, x will now be 3. So let's see if that's going to work. So you see infinite. So let me use print line. So it goes to next one. So you see infinite loop, infinite, and then it stops. So what happened? The very first time, is x greater than 5? That means it's 5 greater than 2. Yes, it printed it. And then this x minus minus is the same thing as saying x minus 1. So it reduced x by 1. So x now becomes 4. Is 4 greater than 2? Print. That's why we have the second one. It reduced it to 3. Is 3 greater than 2? Yes, it prints it. It reduced it to 2. Is 2 greater than 2? No. And then it doesn't do anything again. Okay. So there should always be something to make it false, else you have an infinite loop. So using a while loop to iterate through a list, okay? So let's just do that. Let's create a list and then use that. So what will basically do that, so when you want to use a while loop to iterate through a list, you have to create a variable that will keep track of what index you're currently looking at in the list. So this index variable will keep incrementing by 1 each time until you reach the last index of the list, after which you can now exit the loop. Okay, so let's create a, so let's say we're having, so let me just say, so let's say we are having a party, or creating a party, we're having a party rather. So let's create a list where each element represents the number of guests that, you know, probably accepted the RSVP, okay, from each family. So first family, say 2 people would come, second family says 4 people will come, and so on. So so something like this. Guests per family. So it's going to be a list of two, comma. So the first family said 2 people RSVP. Next family 4 people RSVP. Next family can be 3 people RSVP, and the next family can be 7 people RSVP. Okay, so now let's figure out how many total guests there will be. Okay, let's figure out how many, what will be the total number of guests. Okay, so we'll write a loop to find the answer. So how do we do that? First of all, we're going to create a variable for the total number of guests, and we initialize it to 0 first. So I'm going to say var total guests, and I'm going to make it 0 first. Excuse me. So we'll now initialize another variable for the index variable. Okay, for the index, that is the position of that list. So var index, of course, will start out at 0. So this is how we're now going to use the while loop. So we'll say while, sorry, to change. Okay, so while the index is less than the guests list, which is the guests per family dot size. Remember, the dot size method gives you the number. So while the index is less than the size, remember the index is the position 0, 1, 2. So let's say we have a size of 4. So it starts from 0 to 1. So while the index is less than the size of that list, we're going to do something. So what are we going to do? Okay. So basically, we'll get the elements inside the loop now. We're going to get the elements of the first of the list at the current index, and then we'll add it to the total number of guests variable. So it's just like you're counting, you've counted this, okay, shift, I've counted you, go here. You, shift, I've counted you, go to this place. I've counted you, go to this place. That's just what we are going to be doing. So what I'll just say, I'm going to say total guests. Our total guests now is going to be equal to, well, it's 0 at first. So it's going to be equal to total guests plus guests per family, and then we'll pass in the index. So we'll get, of course, because we are updating the total guest variable, okay, so we'll always have to add it. So we'll do total guest plus the guest per family index. Okay, that means what's particular, the index. So let's say if it's 0, how many, what's the guest person at 0 index? 2. Okay, we'll put 2 inside total guest. That means we have 0 plus 2. What's the next one? The next index is 1, which is the, and what we have in the index of 1 is 4. So it's now be 4. So that is total guest, which is 2, because we added 2 there. So 2 plus what? 4 being 6. That's how it keeps on what going. But after that, we always have to increment the index because we want to be counting from 0, 1, and 2. So I'm going to say index plus plus plus. Okay, so that's big. That's what we want to do. So after the while loop, we can now print out the result. So I'm going to print line. I can say total number. Okay, total number of guests will now be what I'm going to call total guests. I think there's an S. Yes. Okay. So let's run this, and then let's see. Right. So the total number of guests is what? 16, which is actually through 2 plus 4 is 6, 6 plus 3 is 9, 9 plus 7 is what? 16. Okay. So, but this is kind of long. So there's a shorter way to actually do this. So since total guests is actually repeated here, so a shorter way to do this, I'll just say total guests, okay, plus equals. So this is a shorter way to do it. Okay, so if we run that, we should still have the same result. Okay, which is what? 16. Okay, so one thing to note, because doing a simple operation on a variable and storing it back in the variable is actually very common. Okay, so that's why I use this shorthand plus equals operator. Okay, we'll also have minus equals, multiplication equals, division equals, and the like. So it's actually shorthand. Okay, it's actually what? Shorthand, especially when you're when you're doing a simple operation on a variable and storing it back in that same variable. So that's one type of loop, okay, which is the while loop. So let me just put that here. So loops, we just finished talking about the while loop. The while loop. So let's talk about the for loop. Let's talk about the for loop. So a for loop is it actually makes looping through a list much easier. Okay, and it just starts with the for keyword. Okay, so let's clear. Should I clear this or just comment this out? Yeah, let's clear it. Let's clear it. Okay, so it makes looping a bit much easier. So it starts with the for keyword. Okay. Let me do this. Number in. Let me just give you a sample. So this is actually how your for loop looks like. So so the condition for executing the block is actually put in the parentheses. So this is the condition for executing whatever you're going to put in the block. So in this example, the variable number, this number is actually a variable, okay? And it is set to equal the first element in this number list, okay? So what happens is this: the variable number is set equal to the first element of the list, and then the code block is executed. Then the number variable is automatically, we don't have to do plus, it's automatically updated, okay, to be the next element of the number list, and then the code block is executed again. So this repeats for each item of the list until the end of the number list. Okay, so let's actually try that out. So I'm going to create a list of names. So I'm going to say list of, okay, so let's say Ada, Joy, let's say 3 is fine. Or maybe we'll just add 1. But 3 is fine. 3 is fine. Okay, so let's say we have that list. So, and these are list of names. So I could just say for name, okay, in what? Names. So our names, this names is a list. So for each name in the names, in the list of names, what do I want to do? For each name in that list, I want to print the name. It's just an example. Print that name. So when I run it, we should see Ada is runs it. So the first time, remember what we said, okay, that the variable here, the variable now here is the name. So it is set to equal the first element. Okay, so the first element here is what? Ada. So it checks for Ada in names. What should I do? For name in it, so check Ada is the first one. Okay, prints Ada. Joy is the next one. Prints D is the next one. It prints, and then that's actually that. Okay, so now a common operation on list is to do something with each element of the list. Okay, a common operation that you do on list is to do something with each element. So let's do something with each element. I could just say for name in names, this is what I want to do. First of all, I'll get the name. And I'll say number of characters. I could find the number of characters in that name. How do I do that? Number of characters, I can now say, since the name is also a string, okay, I could say, and the string is what? Sequence of characters. So I could just say names dot length. So for every name, it will give me this, to print out the name and tell me the number of what? Characters. So, okay, so length. Okay, sorry, not names. So because these names is the list, so it should be the name. Yes, thank you. Sorry about that. Should be the name. So we can actually see that. Okay, we have for Ada number of characters 3, Joy. So let me add this to kind of spice it up. So Joyce has let's see, 5 characters. The number of characters is what? 3. So this is actually is a common operation actually, when using lists. So what happened is that this code, it doesn't change what happens to the list, okay? It only affected what was printed. So it's actually very cool. So there are some other variations you can actually try out. So just try them out. Okay, so let me just do one. Okay, so you could actually do something like this. Let me create, I can say for, let's leave name now. I could just say something like for item in a range. I can do range of numbers. Let's say 1 to 5. Let's see. Print item. Let's see. There are a lot of things you can actually do. You can just, no need now, I could just call print item. Let's see. Let's see what we have here. Yeah, so you can see for item in this range. So this is a range 1 to 5. Print the item. So the first one is 1, the next one 2, the next one 3. So there's a lot you can actually do from. I can say from item in let's say 5 down to 1. So there's a lot of things you can actually play around with. 5, 4, 3, 2, 1. You can even add a step. You can see something like for item in, let's say 3 to 6, and then you add a step. Step 2. So what does this do? Let's see. Let's run this. So sorry. Range. Okay. So you can see the first one element is 3. Skipped 2 steps. First step is 4. The next one is 5. It's open. It's printed 5. 5 to, suppose after 5 it skipped 1, 6. Skip to the next one, but there's no 7. So we have just 3 and 5. So there's a lot of things you can actually do with this. So you can actually read up on most of them. So Just note, a loop is just a control what flow structure. That's what a loop is. Is a control flow what structure, just like your if, else, and when expressions that we actually learned before. It's like a control because it actually dictates a particular flow for how the code should be what executed. Okay, so let's actually apply what we have learned in a typical use case. I really hope we're able to finish this up. So let's look at ordering a food from a local restaurant. Okay, so there's usually multiple items within a single order for a customer. So using a list, we can actually store information about an order. Okay, you can also draw on your knowledge of classes. We'll also use classes and inheritance to create more stuff. Okay, because we want to actually create something now. Okay, so let's create a program that allows for ordering different combinations of food. Let's write a code for that. Okay, so let's go. Now, so this is what the output is going to look like. So let me just show you what the output will look like. Okay, so we'll have something like this. Order number 1. That is the first order. There's noodles, the person noodles. And noodles is actually 10. 10, let's say 10 euro. Like this. And then the total, to give you the total. Okay, please mute your mic, please. Except you have a question. And then the total, let's say is 10 because that's what we ordered. So we can have another order. Let's say order 2. That takes probably the person ordered noodles and then person ordered fried eggs rather. And then this fried eggs is for 5 euro. So that means the total should be what? 15. Okay. So let's actually write code for this. Now, from this, you can actually see that you can notice that there's a list of orders because you have order 1, order 2. You can notice that there's a list of what orders, and each order has a number. Each order can contain a list of items, just like you have noodles and fried eggs. Each item rather has a price. And then each order has a total price, which is like this is the sum of the prices of the individual items. Okay, so let's create a class that will represent an order. Okay, and then a class that represents each food item, like noodles or vegetables or whatever, or eggs. Now we can even further observe that the noodles and the eggs, they are both food items and they also have a price. So that means we can consider creating an item class with shared properties. Okay, so let's actually do that. So first things first, let's leverage on our knowledge of classes and inheritance. So I'm going to create a class. And then I'm going to call this, first of all, I'm going to call the class item. So let's start low level. Now, the item, each item is going to have a name. And each item is going to have a price. So these are default stuff. They must have a name and a price. Now, we want to now create a Noodle class. So the Noodle class should inherit from the what item. And then we'll pass in, noodles as the name. And then, of course, we have to pass in a price. So let's say 10. Now, of course, remember, because this is not abstract, we have to open this up. Okay, good. And then, so let's say class eggs. Okay. And then, of course, inheriting from the item. So inside here, we have fried eggs. And then the price is 5. So we have just created a class now. So in our main function, let's now create some method objects. So I'm going to create a noodles object from the noodles class. Okay, and then I'll also create eggs from the eggs class. That's the object. So let's do something. I want to print, let me print noodles. And let me print eggs. So if I run this, okay, so okay, noodle. Let me just make these noodles. Okay. So we have okay, so the integer literal, okay, sorry. Price should be of type int. Yes. So you can see this is what it gives us. This is what it gives us. So let me explain this. Let me explain what you're seeing. So first, okay, there's a class called item, okay, that where the constructor takes two parameters, a name for an item as a string and the price as an integer. So both properties do not change after they are passed in. So they are marked as val. That's why they're marked as val. So since item is a parent class and subclasses extend from it, that's why we have the open keyword. So I'm just trying to explain. Now we have the noodles class constructor that takes in, it doesn't take in any parameter, but it extends the item and at the same time calls the super class constructor. So we called it by passing in, the properties, which is the noodles, and then which as the name and then the price. The X class, the same thing, okay, but it calls the super class with what fried eggs and then 5. Now, but the main function, that's where we are initializing new object instances of the noodles and the eggs what class. And then this is what we are given. Okay, so basically what you're just seeing there, okay, basically what you're just seeing there is just the address, okay, the memory location. That's just what you're seeing, the 20 AD and that. So, but how do we, change this? So this is where we'll talk about the toString method. Now, when you print an object instance to the output, okay, this is an object instance, eggs, noodles. You're printing out the instance, the object. What happens is that the object's toString method is called. So in Kotlin, every class automatically inherits the toString method. Okay, so the default implementation of this method is that it returns the object type with a memory address. That's why you see it. This is the object type. You can see what's the object type. It's of noodles with the memory address, the location for that instance. So we can override it. Okay, we can override the toString method so that it returns something more meaningful. Okay, so how do we do that? Now, all I'm just going to do, so for the noodles, I'm just inside here. I'm going to say override function toString. Okay, which actually returns a string. And what do I want? I will now return. What do I want to return? Let me return what's name. Yeah. So I return the name because this name is this one, of course, or this one at the same time. So let's run this and then let's see the difference. So you can see. So this returns the name. For the noodles object, when we're printing the object, since we have overridden the toString method, that actually just gives us the constructor, the object type and memory location. Here we have overridden it. We are now returning the name. That's why we have noodles. But we have not done it for eggs. So I could just copy this. Then running that now, you see noodles and fried eggs, but I'm returning only the name. Okay, I could return price. Let's see, but price is actually, oh, this should give an error. Let's see. Yeah, type mismatch because infer type is int but string, so it was expecting a string here. So what if I say dot to string to convert it? So this then gives us the word price because I converted it to what string. Okay, so that's just to note. So let's now change the eggs class constructor so that it takes in some parameters. Okay. So let's do some customization. I want a situation whereby okay, so let's just okay, so interesting. Okay, so let's move on. So I want to, pass in some more stuff. So let's say for the eggs, let's say I want to fried eggs, boiled eggs. Okay, so that's that. So, okay. Yeah, but this is actually going to give us an error, of course. Too many arguments. We didn't even, so we need to specify it, when we are here. So I'm going to specify that. So I'm just going to say egg type, just call that. It's going to be of type string. So what kind of egg do you want? Okay, so I added 2. So let's add 2. So egg type, excuse me, egg type 2. So this should be egg type 1. Okay, so running that, I think it's going to be fine. Okay, so sorry, type string. Okay, so yeah, so but this is still giving us just so this is giving us fried eggs. Because that's what we passed in where here. Okay, so let me change this to just eggs so we're not confused. Okay, so yeah. So let's see. So let's actually now call it in the okay, so that's fine. So now we need to, yeah, so I think this works now. So for the eggs, so instead of returning name, okay. Now I could actually make an adjustment. So let's do something. So instead of using one property for each type of for each type of egg, okay, so we can actually update this and then just have something, could have something like this, could have, let's say, egg type, and it should now be a list. Okay, yes, could now what be a list. So that means I can pass in as many as I want. Okay, I could pass in as many as I want. Well, but this is not the best actually, because it just means that these are the best of solutions, because it now means that when I pass in X, I should now say something like list of, then I'll say bold. Let me just say bold. Right. Right. Okay, so let me just take out this guy first. Okay, and then let's run this. So you can see, because we are printing out this, so let's return egg type. Let's return egg type. And then, okay, so infer type is list string, but string was expected. Okay, so I need to change my to string method, so list also, or it's either that, I can't actually, I knew I suspected that. So instead of changing it, why don't I, well, I can get, you can actually get a particular, what they call it? What do they call it? Getting a particular element, okay? Since we are returning a string, so you can get a particular what element. That's if you're using the override to string method, okay? You're overriding the to string what method, okay? But let's do something. Let's do something. So instead of having to use this list, okay, you can see there's an issue. So what the best one we can actually use, Kotlin has what we call a var arg, that is VARARG, that is a modifier that allows you to pass a variable number of arguments of the same type into a function. Okay, so instead of doing this, I could just say var arg val, then I'll say egg type, and then of type string. Okay, I could actually just want to do that, and then to override this, to display that, I can actually now return the name. Okay, I can return the name. So let's just do this first. So I think I can just take this out, the list of. So let's just run this and just to be sure of a few things. So we are still having eggs because it's returning just the name, but I want to add something. So I'll say return name, and then plus. Okay, so let's see. Let me give it space. Okay, there's actually space. Then plus, I will say egg type, and then there's a method called join to string. Okay, join to what? String. Yes. So yeah, that's that. So let me run this. So you can see, so it joined these two, which is the bold and the fried. It joined it to the word string. Okay, join to what? String. So that's actually another way. So this is basically to specify different separator other than a comma. Okay, so they specify that a different separator, we can actually just use this. This is space. Okay, and then at the same time, okay, you can also pass in, pass this in here. You can also specify, by doing this to separate each item with a space. By default, it uses a comma by default, but you can choose to use a space to do that. So when you're writing programs, okay, you really need to consider all possible inputs, okay? Because when there's no input arguments to this egg constructor, the eggs constructor, you can handle the toString method in a more user-friendly way. So, for example, since let's say the customer, okay, doesn't want let's say eggs, okay, but didn't say which one, because you have whether boiled egg or fried egg. He didn't say which one, okay. So one solution is to just give them a default of probably the restaurant. Maybe if you did not specify, you just tell me give me egg. There should be a default. Okay, maybe the default could be boiled, the default could be fried or scrambled. Okay, so how do we do that? We can actually specify that in the toString method. Okay, I'm just going to do that by saying if egg type, okay, dot is empty. So we're checking if it is empty. What do? We'll give it a default type. We'll return name, chef's, we'll say chef's choice. Okay, but else, if it is not empty, that will give you that. So let's test out. So first of all, let's run this. So to test out that, so of course it's not empty, so it gave us this. So what if it is empty? Let me see. Okay. Let's see. It's still running, so I'll wait for that. Okay. Yeah. So we didn't pass in anything. So that is still running. I don't know, maybe it's my network. Okay, but that's fine. So you can see eggs, chef's choice. So it just gives you, the default. So we are the ones, we just say the name should be the chef choice. So now that we actually have some food items, let's create an order. So we'll put the logic for an order within an order class. So we create an order class and put the logic there. Okay, so looking at this, you can actually see what we did. This is an order. So it has an order number, the items, total, and the likes. So let's create an order class. So here, close this out. So I'm going to say class and then order. So a class, okay, by default should have what? An order number. So every class must have an order number. So we're basically just focusing on properties, okay? So let's see. There are a lot of ways you can implement this, but this is just one way to create a class order that has an order number called parameter only. Like when you want to, create an instance, you create an instance with the order number. So just think of it like an index or something. Okay, so every other thing can now come inside. So you can have a list. So I'll say item list. Okay, and of course, it's going to be a mutable list. So mutable list of, and then of what? Mutable list of what? Items. Okay, item rather, since it's just singular. So it's going to be a mutable. So it's going to be a mutable. So to create a list, it's going to be a mutable list of what? This item. Okay, because since we may not know all the items in the order up front. Okay, so we don't require that the list of items, to be passed in as an argument. That's why we have just order number, because the list we may not actually know everything at once. So instead we can just declare it as a top level class variable, which is what we're doing here, and then initialize it as empty. Okay, so that it can hold elements. Okay, and then of course private, so that only this class can modify the list of items. So, okay, so basically this will just prevent it from being modified in unexpected ways by codes outside this class. So we can now add other methods, okay, to our class definition, okay. So one method we could add is a method to add an item to the list. And to add an item, we are going to need to pass in a new item of type item. That's all. A new item of type what? Item. We have another one, maybe to add all. And of course, it's just new items still from a list of, remember when we used add, the add all is in here from a list of what? Item. Okay, so these are two functions. Okay, and then of course we could actually just have the last one to print the order. So function print, of course, we don't need to pass in anything to print it. So the add item method, okay, means it's actually very much straightforward because so we implement that first. So what it does is that it takes a new item, okay. So how we just do that is very simple. So I'm just going to say item list, okay, which is the item list that we created. Item list dot what? Add. And what are we adding? The new what? Item. That's all. Okay. So for the add all, okay, so just say item list dot add all. And then what do we pass? We're going to pass the what? New items. So now then to implement the print, okay, this one prints a summary of all items and their prices, okay? So first we have to print out the order number. Then we have to now use a loop. So let's just do it one by one. So first things first, based on what I say, you have to print out the order number. Then of course, from this place, you see that we have like two items, so it's like a list. So we need to what? Use a loop to iterate through all the items in the order list, printing out each item and their prices, okay? Also, we have to keep a total of the price so far, okay? So let's do that. Let's do that. So first things first, we'll print the order number. So I'm going to say print line order so I'm going to say what? I'm just going to call order number. Okay. So you can be wondering where the order number is. Yes, from here. Okay, this is it. Now, so we'll create a total variable because we need to keep track. And of course, its default to be 0. So the next thing is to what? Iterate through. So I'm going to use a for loop. I'll say for item in the item list. Okay, what do you want to do for each item in the item list? We want to print that item. We want to print that item. So we want to print the item. Okay, so want to print the item and want to also print the item price. Okay, want to print the item what? Price. And once we are done with that, we now what? Get the total. So the total is going to be plus equals item dot what? Price. So total plus equals item price. What that means is total equals to the previous total plus what? Price, plus the item dot price, which is the price. Okay. And then after that, we can now what? Print line total okay, sorry, I need to put this there. Yeah, so total is what? Total. Yeah, hello, can you hear me? Can you hear me? Please confirm you can hear me, please.
Yes, sir.
Yeah, so sorry about that. My network actually. Okay, can you hear me now?
Yes, sir, we can hear you now. Hello?
Okay. I think I was muted. Wow. Okay, so basically just creating orders. So we have the order one of the so order class will pass in one, and then we add items. So the item we're passing is the noodles. Okay, remember we are returning this. So and then so we have three orders now. So this the last one, and then of course we can now say order three dot add all. And what do we pass in? Items. And then finally we'll just print. Okay. Okay, so let's see. I hope there are no I hope there aren't any errors. So let's run this and see what we have. Well, there are errors, will fix it. So that's all. So you can see order one. Okay. So why did we have an extra curly brace? So I think it's from our order. Okay, yes. This wasn't necessary. So let's run this again. So we can see the order one, okay. After adding the item, it added so noodles. So we added item and added noodles. And what did we? I think we're actually getting the price. So let me return this back to name. Okay, let me return this back to name. Yeah, so we have noodles, okay, and the price is what? 10. Okay, let's say 10 euros. Okay, and then total is what? 10. Okay, the print function, remember what the print function does? It prints the order number, the total 0. So for item in item list, so the item we sold was just what? Noodles, which was 10. Order 2, you can see noodles, and then 10, we added noodles. Now we added the choice. So because we did not specify the particular egg, okay, it gave us the default, which is what? The egg chef's choice, and the price is what? 5, and the total is 15. Okay, so I didn't use a print line here, so that's why that's why they are joined together. So let's run that again. So there's a bit of space. Okay, sorry. Not here. Not here. Not here. Okay, so print line. Okay, yeah, so I didn't add this in between, so. Okay. So there should be space now, yeah. So order 3, you have noodles, you have eggs, scrambled eggs. So the kind of eggs we need is a scrambled what? Eggs, okay? And then the price is what? 5, and the total also is 15. Okay, so that's actually we are actually out of time. Okay, let's just do this one last thing, just to improve our code. Okay, now we need to keep a list of orders, because if you are building a program that would actually be used in a shop, okay, to be able to keep track of a list of all the customer orders. So we'll create a list to store all the orders. Okay, so we'll create a list. So we'll do that in the main function. So I'm just going to say val order list. So we're going to use a mutable list of, and it's going to be a mutable list of orders, rather, because we don't have any class named orders, plural. So I'll create that. And then what do I want to do? After all this, after creating these objects, I'll now say orders list dot add. Okay, so I could actually yeah, so I would have to just do it one by one. So I say order 3. So that is, so immediately it's done. So this is it. So immediately it's done. So here I don't actually need to print anything, but let's just see. So I will take out, let's take out this print. And then we'll print later. So immediately it's done, let it add this order 1 to the list of orders, and then take out this. Let's add order 2 to the list of orders, and then order 3. Okay, so we don't actually need this for now. No, we don't. Okay, don't also need this one. Okay, so don't also need this one. Okay, so after that, we can now actually just print it if you want to. Because since the orders get added over time, the list should be mutable list. Okay, that's just that. Then we use the add function. So as you create an order, we add it to the list of orders. So we can now print out, let me just print out a blank line here, print line. And then to print out the orders in the list, I would say for order in orders list. Okay, I'll now say order dot print, which is the function that we created. And then I'll just print an extra line so that there will be space. So I think I can actually take out this one. So let's run this. Okay, so we have an error somewhere. Where are we? Function invocation for print, where? Mutable list of order. Function invocation, mutable list of order expected. Okay. Yeah, function invocation. So we need this. Sorry about that. So you can see, so we have this. It still prints out the odds, the orders. Okay, this looks much more, instead of having print statements everywhere, you can just use a loop to print out that. Okay, so so lastly, let's implement what we call builder patterns for our orders. Now, to make your Kotlin code much more concise, you can use the builder pattern for creating orders. Now, your builder pattern is a design pattern in programming that allows you to build a complex object in a step-by-step approach. So what I'm saying is, so instead of returning units or nothing from the add item, like you can see our add item here, our add item function is not returning anything, or is returning units. It is not returning anything. So instead of returning units or nothing from the add item and the add all function or methods in our other class, we can return the changed order. Okay, we can return the word changed order. So Kotlin provides a keyword called this to reference the current object instance. So here I can now say return this. Also here I can say return this. So, but return what? I want to return what? The order. So after you add item, return the order. After you add item, return the what? Order. Okay, so in our main function, we can now chain the calls together, okay, to create a new order. So I can now do something like this in my main function. I can have something like this. Let me just comment it out first. I can now use a chain. I can now say, let's say val order 4 is equal to, I say order, okay, 4. I'm creating another instance, but with that I can now say dot add item which we have noodles. Okay, dot add item. And here we're gonna have eggs, of which I can now pass in, let's say, scrambled. Can also pass in bold. Let me just pass in bold or fried. Okay, so this is like a you can chain the calls together. Okay, so this is just going to create a new order and to take advantage of the builder pattern. Okay, so at the end I can now say order list, orders list dot add, and then I can pass in order 4. Okay, can pass in what? Order 4. So this order 4, this guy, okay, it returns an order instance, okay, which we then call the add item and passing the noodles on it. The add item method now returns the same order instance. Okay, it returns the same order instance with the new state. And then you can also call the add item again on eggs, the eggs class, and the returned order results can now be stored in this variable. Okay, so now this other code we have here, it still works, so you don't have to remove it. It still works. Okay, but it's not mandatory to actually change these calls like this. It's not really mandatory. Okay, but it's actually common and recommended practice that you take advantage of functions that return a value. So at this point we don't actually even need to store the order in a variable. Okay, we don't need to store the order in a variable. Okay, we can just let's see. We can just do something like this. So instead of this whole order list dot add, can just okay. Sorry. So we can do something like this. We can say something like orders list rather, as list of orders dot add, and then I'll create. That's if I don't want to create a variable. I'll create an order instance with 5. That is the 5th order. Okay, and then I'll just say dot add item, and then I'll pass in the item noodles. Okay, add the dots again, just dot add another item, and then this one could be, let's add another noodles, and then dot add item, and then this could be, say, eggs, and then could now pass in bold here. Okay, so let's run this and then let's see what we have. Okay, we are fine, no errors, so I can take out this so that we can print. So we have our order 1, which is how we did it before, still working. We have an order 2, we have the order 3. So from the order 4, even when we did the chaining, it was still working. We have our noodles, we have our scrambled, and we have our fried. And then of course, this is where we did not have to actually store it in a variable. We could just create it, directly. So just add, and then we'll add the order. Okay, so which actually still works fine, total of 25. Okay, so that's actually that. Okay, yeah, we're able to complete that. So that's that. Any questions? Round it up now. Any questions before we round up? Okay, so in the absence of no question, okay, so thank you very much for joining the class. Apologies for the network glitch. Okay, so I believe that won't actually happen in the next class. Okay, so thank you very much. Have a wonderful night's rest.